Dear learners, good evening. Today we will learn about one of the public key cryptography algorithm, that is RSA algorithm. RSA means reverse Shamir-Adleman. These are the inventors of the popular RSA algorithm. This algorithm is based on public key cryptography. This RSA algorithm is a public key crypto system which is used for secured and reliable data transmission. Before we look into RSA algorithm, let me explain what is public key cryptography or the basic concepts of public key cryptography, because RSA is one of the public key cryptography. So in public key cryptography, two related keys are used. As we learned already, one of the key is used for encryption and another key is used for decryption. So in a public key cryptography, two related keys are used. They are named as public key and private key. Public key may be freely distributed while its paired private key remains secret. Public key is used for encryption and private key is used for decryption. Encryption means converting the data from meaningful form to meaningless form, and decryption is reconverting the meaningless data into meaningful form. So for encryption process, the public key is used, and for decryption process, the private key is used. Okay, so this picture depicts the public key crypto system, where if you want to transfer data from person A to person B, let me consider person A as a source and person B as destination. Now every user will generate a pair of keys, that is public key and private key. So the receiver, that is person B, generate two keys. They are named as public key PUB and private key PRB. And the public key is announced to the public and the private key is kept secret by the person B. Now whoever want to transfer message in secret to the user B, then the user will use the public key of B for encryption. So here person A will convert the original message X into ciphertext Y by using an encryption algorithm, and this encryption algorithm make use of the public key of the receiver B. Now here Y is nothing but the ciphertext which is meaningless form, and Y is nothing but is equal to encryption of the data message X by using the public key PUB, and this Y is transferred to our network, and that Y will be received by the receiver, and the receiver will decrypt that Y value by using his own private key which is kept secret by him. So the original message X will be obtained by decrypting the value Y using the private key B by decryption algorithm. Now, while the ciphertext is on transfer, the hacker may get that value Y, but it is not possible for a hacker to decrypt it without knowing the value of the private key PRB. PRB, that is private key, is known only to the receiver B and nobody else know the value of the private key. So that is the strength of this algorithm. Now this principle is used in RSA, and RSA they introduced an algorithm called RSA algorithm for secret data transmission using this public key crypto system. Now, what is public key crypto system, or what are the concepts of public key crypto system is? it must be computationally easy for a person, for any person, to generate pair of keys, that is public key and private key. And it is computationally easy for a sender to generate the ciphertext knowing the value of the public key and the message M. So it is done by an encryption algorithm. So the ciphertext C is equal to encrypting the message M using the public key PUB. And the receiver will receive the ciphertext C, and this ciphertext will be converted into message M by using decryption algorithm. This decryption algorithm make use of the private key PRB, which is known only to the receiver B. But what is the strength of this algorithm is, even though the hacker know the value of public key, it must be infeasible for an hacker to determine the value of the private key PRB. Even though PRB and PUB are related to one another, but it must be infeasible for an adversary to determine the value of the private key PRB, even though he know the value of PUB. And the second part is, it must be computationally infeasible for an hacker knowing the value of PUB and the ciphertext Y to recover the original message X, because while the message is on transfer, the hacker may get the value Y, and he already knows the value of B, that is the public key. Even though he knows the value of Y, that is ciphertext and the public key PUB, it must be infeasible for a hacker to derive the original message X from the ciphertext, because the original text X can be derived from the ciphertext only by using the private key PRB. Now, based on this public key crypto system, RSA introduced an algorithm called RSA algorithm to transfer the data in a secured manner. Now, let us discuss about the concepts behind RSA algorithm. So, this RSA algorithm make use of expression with exponentials. I said the pair of keys, public key and private key, are mathematically related to one another. And here, how they are related means, in this algorithm, they use exponentials. Okay, here the plain text is represented as an integer number n. And the encryption algorithm is done by, that is, ciphertext is equal to the message, original message M, to the power E. E is nothing but encryption key, the key used for encryption, which is a public key, mod n. N is nothing but some number. And decryption algorithm is M is equal to C, that is ciphertext raised to the power of D. D is nothing but the decryption key, mod n. Here E is the key used for encryption and D is the key used for decryption. Both sender and the receiver knows the value of n. N is some common value which is known to everybody. And the public key is nothing but E and N, because E is the key used for encryption. Whoever wants to send a message in secret will make use of this key E to encrypt the message. And the private key is D, N, and D is the private key which is used for decryption to convert the ciphertext into plain text. Now, according to RSA algorithm, how they are going to generate this E and D, that is pair of keys, key used for encryption and decryption is given here. First, we have to choose two large prime numbers. Let the numbers be P and Q. From that, we are going to calculate a public value, that is N. N is nothing but that is equal to P into Q. You have to find the product of the two prime numbers. And then you have to compute a value called pi of N, which is nothing but is equal to P minus 1 into Q minus 1. Then you have to choose an integer E, that's a number, which is used as for encryption process. You got to choose in E in such a way that this E must be greater than 1 and less than pi of n. We know the value of pi of n. That depends upon the value P and Q. Yes, okay. So here the encryption key is chosen in such a way that it is greater than 1 and less than pi of n. And moreover, we have to choose E in such a way that E and pi of n are relatively prime. What do you mean by relatively prime? Means pi of n and E will have common divisor as 1. So in that case, you can call E and pi of n as relatively prime numbers. Then you got to choose a value for D, that is a decryption key, in such a way that E into D must be equal to 1 mod pi n, or you can calculate D in such a way that D is equal to discrete logarithm E power minus 1 mod pi of n. After choosing the value of E and D, you can make use of E and N as public key and D and N as private key. Already N is nothing but is a multiplication of the two prime numbers P and Q that will be announced to the public. Everybody knows the value of N, and E is also announced to the public. That is the key used for encryption, but D is kept secret. How to choose E and D? That's a step given here. You have to choose E in such a way that it is greater than 1 and less than pi of n, and E and pi of n are relatively prime numbers. And after choosing E, you have to choose D in such a way that E is equal to E power minus 1 mod pi of n. Okay, here is an example for that value. Take two prime numbers, 17 and 11. 17 as P and 11 as Q. From that, you calculate the value of N. N is equal to P into Q, that is equal to 187. And you got to calculate the value of pi of N. Pi of N is equal to P minus 1 into Q minus 1, that is equal to 16 into 10, that is 160. Now, you have to choose a value E, which is less than pi of N, that is 160. And that is a prime number. Mostly, you can choose it as a prime number. So, here, we select the value of E as 7. Now you have to determine D in such a way that ED is equal to 1 mod pi n. Here we can choose D as 23. So the public is E and N. So E is nothing but 7 and N is 187. So public keys are 7 and 187 and private key is 23 and 187. Using this, we can calculate, encrypt the message. Let me consider you want to transfer a message M. Let me consider the numerical value of that message is 88. That is M is equal to 88. From this, you are going to calculate the ciphertext C. C is equal to message raised to the power of E, that is encryption key, mod N. That is equal to M is 88 raised to the power of encryption key E is 7 mod N is 187, that leads to 11. Then you are going to transfer this 11 as ciphertext and the receiver receive the 11 as the input. Then from 11 he can calculate the plain text M by using the formula M is equal to C, that is ciphertext raised to the power of decryption key mod N. So that is equal to 11 raised to the power of 23 mod 127, that is equal to, if you compute this value,